Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about properties of Gaussian density function. So there are some important properties of the Gaussian density function that are first one, the normal curve or the bell curve is the normal curve is a bell-shaped curve. The normal curve is a bell-shaped curve and it is symmetrical about its mean. X is equal to m, the normal curve is a bell-shaped curve and it is symmetrical about its mean. That is the first property. And the second property is the area enclosed by the Gaussian density curve is unity. So that is integral minus infinity to infinity f of x dx is equal to 1. So now prove this area enclosed by the Gaussian density curve is unity. So let us consider integral minus infinity to infinity 1 by square root of 2 pi sigma square. And what is the Gaussian density function expression? 1 by square root of 2 pi sigma square e power minus of x minus m whole square by 2 sigma square dx. So consider that one. So now here in this equation x minus m by sigma is equal to small t. X minus m by sigma is equal to small t. Differentiating with respect to x, dx is equal to sigma dt. So from this equation x minus m is equal to sigma t. And now here in this consideration, and what are the ranges of the x ranges are minus infinity plus infinity. Now we are considering x minus m by sigma is equal to t. So now calculate the values of the ranges of the t. In this consideration, substitute x is equal to minus infinity, then t is equal to minus infinity. If x is equal to plus infinity, then t is equal to plus infinity. And the values of the t is also minus infinity to plus infinity. So applying these considerations in this equation, we get integral minus infinity to infinity fx of x dx is equal integral minus infinity to infinity 1 by square root of 2 pi sigma square e power x minus m by sigma is equal to t. So e power minus t square by 2 dx is equal to sigma dt. So now we are in the denominator, square root of sigma square is sigma, numerator and denominator sigma is the cancel. We get RHS term is 1 by square root of 2 pi integral minus infinity to infinity e power minus t square by 2 dt. Okay, so what you can prove, the area enclosed by the Gaussian density function is equal to 1. So that is integral minus infinity plus infinity fx of x dx is equal to 1. So because of that, the RHS term of this integration, I am considering another variable, that is capital I. Capital I is equal to 1 divided by square root of 2 pi integral minus infinity to infinity e power minus t square by dt. This is the I value. This RHS term is the I value. Consider I into I. I into I is I square. So I into I, first I is 1 by square root of 2 pi integral minus infinity to infinity e power minus t square by dt into second I, change the variable 1 by square root of 2 pi integral minus infinity to infinity e power minus s square by 2 ds. I into I square. So 1 by square root of 2 pi into 1 by square root of 2 pi, 1 by 2 pi, integral minus infinity to infinity into integral minus infinity to infinity. So this exponential term and this exponential term is written as e power minus of t square plus s square by 2 into ds into dt. So the polar form representation or the polar coordinate system considerations are s is equal to r cos theta and small t is equal to r sin theta. So ds dt is equal to r dr d theta, and s is equal to this and t is equal to this. T square plus s square is equal to r square cos square theta plus r square sin square theta. So which is equal to r square. T square plus s square is equal to r square. and theta is varies from 0 to 2 pi and small r is varies from 0 to infinity. So these are the considerations from the polar coordinate system. For polar coordinate system, so these are the considerations. Applying these considerations into above expression. Above expression means this expression, RHS set of this expression. So we get I square is equal to, and theta is varies from 0 to 2 pi, small r is varies from 0 to infinity, 1 by 2 pi e power s square plus t square is r square, so e power minus r square by 2 ds dt is r dr d theta. And from this equation, separately simplifying, integral 0 to infinity e power minus r square by 2 r dr value. Separately, first simplifying, integral 0 to infinity e power minus r square by 2 r dr. So r square by 2 is equal to t, differentiating with respect to t, 2r dr by 2 is equal to dt. So r dr is equal to dt. So now here, what are the values of the r? R is varies from 0 to infinity. Now here r square by 2 is considered as small t. Now calculate the values of the t. If t is if r is equal to 0, then t is equal to 0. If r is equal to infinity, then t is equal to infinity. And the t is also varies from 0 to infinity. So therefore, integral 0 to infinity e power minus r square by 2 r dr is equal integral 0 to infinity e power minus t dt. R square by 2 is t, e power minus t dt. So integrating e power minus t, So e power minus t integration is e power minus t divided by minus 1 over 0 to infinity. So applying upper value and lower value of t, minus of e power minus infinity minus e power minus 0. So e power minus infinity value is 0, e power minus 0 value is 1. So 0 minus 1 minus 1, minus of minus 1 plus 1. So after integrating, applying the upper value and lower value of t, finally we get this integral value is equal to 1. Okay. Integral 0 to infinity e power minus r square by 2 r dr value is equal to 1. Substitute this value into this equation. Integral 0 to infinity e power minus r square by 2 r dr is 1. And substitute that value into this equation. We get from this equation I square is equal 1 by 2 pi integral 0 to 2 pi 1 d theta. Integral 1 d theta theta over 0 to 2 pi. Okay. Integral 1 d theta over 0 to 2 pi. After applying the lower value and upper value of theta, 2 pi minus 0 is 2 pi. So 1 by 2 pi into 2 pi, 2 pi is the cancel 1. I square is equal to 1, I is equal to 1. And what is the I? That I is equal 1 by square root of 2 pi integral minus infinity to infinity e power minus t square by 2. And this is the value RHS term. So this value is equal to 1. So therefore, integral minus infinity to infinity f of x dx is equal to 1. So therefore, the area under the area enclosed by the Gaussian density curve is unity, that is integral minus infinity to infinity f of x dx. But f of x is equal to 1 by square root of 2 pi sigma square e power minus of x minus m whole square by 2 sigma square dx is equal to, this is the density function. Next, third property, the maximum value of the Gaussian density function. So the Gaussian density function reaches a maximum value at x is equal to m. So the Gaussian density expression, and what is the Gaussian density expression? This is the expression of the Gaussian density expression. In this Gaussian density expression, substitute x is equal to m, we get maximum density value at x is equal to m. That is one of the property. In the concept of Gaussian distribution concept, this is already explained. And fourth property is the Gaussian curve has only one maximum point and hence called as unimodal curve. These are the some important properties of the Gaussian density function.